Okay, hello everyone. So in the previous video, we actually watched how we use sodium hydroxide to actually test for metal cation ions, and we have learned that the hydroxide ion actually reacts with the metal cation ion like this, right, to form the precipitate. And this precipitate will be different colors and different solubilities. We learned that copper 2 ion is for light blue precipitate, iron 2 green, iron 3 reddish brown. Calcium, lead, aluminum, and zinc, they are all white, 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 white. But calcium hydroxide, because it is a basic hydroxide, will not dissolve. However, our LAZ, because our LAZ, right, is amphoteric, it will dissolve in excess sodium hydroxide. So therefore, it is very hard for us to test for lead ions, aluminum ions, or zinc ions using sodium hydroxide. So we need to use our next one, which is our aqueous ammonia. Now, aqueous ammonia is a weak alkali. So aqueous ammonia it has low concentration of OH minus ions. And because it has a low concentration of OH minus ions, right, the excess, when it have excess NH3, the reaction is slightly different. So the precipitate is still the same because we are reacting with the OH minus ions. So we still have our light blue, copper 2 hydroxide, green, iron 2 hydroxide, and red brown, iron 3 hydroxide. But it's very interesting how for excess ammonia, the light blue precipitate, so the PPT dissolves for copper to form a very dark blue solution. And this is something that you need to remember. So I think this is actually special. So you need to remember that it is soluble in excess and it dissolves to form a dark blue solution for copper 2 hydroxide in ammonia. Right? For iron 2 and iron 3, again, it is not soluble in excess. And for calcium, because calcium is actually sparingly soluble, over here there is no precipitate. You have no visible reaction over here. Nothing. Okay? So for my lead 2 ions, my aluminum ion, and my zinc ion, you still get the same white precipitate, white precipitate, white precipitate. But for my lead 2 ions and my aluminum ions, it will be insoluble in excess. Okay, in this case, we do not talk about it being amphoteric because ammonia is a weak alkali. So it has a very low concentration of OH minus. So we are not so interested in it being amphoteric. Instead, right, is something else that happens which you don't really need to know, but this is an observation that you need to understand. That when the zinc precipitate, which is the zinc hydroxide, is added to excess ammonia, the zinc hydroxide is soluble in excess. And it's soluble in excess, right, ammonia, and it will form a colorless solution. So this is also something special that you need to know, right? And it's something that helps you remember. Over here, this is lead hydroxide also. Let me just write the chemical equation, and this one is aluminum hydroxide. Just let me help you write the chemical equation. Okay, and you might be wondering, wow, there's so many things to remember. I need to memorize all of this. How do I remember it? So this is how I like my students to remember. Okay, we have two groups of ions. We have the colored ones over here, right? These are colored, and we have the white ones, which are over here: calcium, lead, zinc, and aluminum. So we have the colored one, which you must remember the color. So it's copper is blue, iron 2 is green, and iron 3 is reddish brown. And we need to remember the colors, and we also need to remember the solubility. And for sodium hydroxide, you need to remember that they are all insoluble in excess because they are all basic hydroxides, except my amphoteric ones over here. So I will draw one box over here to remember that I need to first remember that it's the colored, the white, and then with the amphoteric. So I'm going to number it. So firstly, the ones that are colored, remember the ones that are white, And then remember that amphoteric will be soluble in excess sodium hydroxide. Then we need to remember that calcium is insoluble, has no PPT in ammonia. So that's something else to remember. That's the fourth thing. And then the fifth thing is that this is special. Copper 2 ions, copper 2 hydroxide is soluble in excess ammonia to form a dark blue solution. And the sixth thing is that the zinc hydroxide is soluble in excess to form a colorless solution. So you really need to practice, because there's actually quite a lot of things to remember, and you really need to remember it. But I'm very confident by the end of these lessons, right, you will be able to remember it very well. Now, we need to know what is the reaction that's happening. So for copper, let me give you some examples. We have the copper 2 ions, which is in aqueous state, and it reacts with the hydroxide ions, which is in the aqueous state, to form my copper 2 hydroxide, which is in a solid state. And when I balance it, it will be a 2 over here. Okay, so learn how to write this type of ionic equations, right, to form the precipitate. Let me do the iron 3 for you. So we got the iron 3 ion, which is in the aqueous state. It reacts with the hydroxide ion, which is in the aqueous state, and it will form my iron 3 solid, right? And in order to balance this, I need 3. Okay, so I will do one more with you, but I need you all to fill up all of it so you can practice. Let's do the zinc one. So I got my zinc ion in aqueous state. It reacts with my sodium hydroxide in aqueous state, and then it forms my zinc hydroxide like this formula, and then I need to balance the equation. So it's over here. Okay, so I went through how to remember the 6 points to remember, fill up the rest of the equations, practice and practice and practice, and I'm sure you'll get a lot better at it. Okay, so all the best. See you for the next video. Bye.